Hello, good morning. Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important classical mechanics topic. Already, I am informing you in YouTube channel. We have one app is there. In that app, we started the course that is the CSIR and Gate Physics course. Now we are teaching the classical mechanics live classes and recorded classes also available on that app. Anyone interested to take the course, you have to go to the course and Play Store and download our app and see the stores and see the courses in our app, and then you decided whether you have to take or not. First, in classical mechanics, I told you, in classical mechanics, core and advanced syllabus is there. In the CSIR examination, there is a core and advanced syllabus is there. Suppose if you have to take a core syllabus of the CSIR and advanced syllabus of the CSIR, once you have to observe, in the core syllabus, the first topic is the Newton's laws. The first topic is Newton's laws. That's why 3 questions I took from this Newton's laws, and I explained that one. The second topic is dynamical systems. In the dynamical system, we have the phase space dynamics is there. Phase space dynamics. In the dynamical system, we have phase space dynamics, correct? In advanced part also, the same syllabus is quoted. In the dynamical system, phase space dynamics is there in advanced part also. Clear? So now from this phase space dynamics, very important. Recently, every CSIR examination, they are asking the question. One simple question I am taking for concerning you. First, you have to see, whenever asked this question, CSIR December 2011, they are asking this question. The trajectory on the ZPZ plane, phase space trajectory of a ball bouncing perfectly elastically of a odd surface at Z is equal to 0 is given by approximately by neglected friction. You have to neglect the friction. How we have to solve? First again, once again, you have to see options. They are giving the diagrams. They are giving not the values. So what is the diagram? We have to identify, because that is a phase space trajectory or phase space trajectory or phase portrait or phase flow or phase plane. So we have to identify. How we have to identify? Once you have to see CSR December 2011, the trajectory on the ZPZ plane. What is the thing? Once you have to see the trajectory on the ZPZ plane. So there is a ZPZ plane is there. The trajectory on the ZPZ plane. So what is the trajectory? We have to calculate the trajectory on the ZPZ plane. Clear? I am considering a ZPZ plane. Now you have to see on the surface. Maybe you have to consider this is the surface of the Z plane. You have to consider this one is the surface. Now you have to take one ball. So that ball mass is equal to m mass is there. You have to consider the ball. You bounce the ball. So what will happen? The ball is going to move in upward direction. In what direction it is going to move? From here it is going to move. In how much height is there? H height is there. This ball cannot stand every time. It is going to come. This ball is going to come in the reverse direction. This ball is going to come. Right now you have to see find the kinetic energy of this bouncing ball is equal to pz square by 2m. The potential energy of the kinetic ball is equal to, what is the potential energy? mgz. So therefore you have to write the total energy is equal to kinetic energy plus potential energy. Now you able to get the total energy is equal to pz square is divided by 2m plus potential energy is equal to mgz. So this one is the total energy of the system. Now this energy also going to take this side. 1 is equal to pz square is divided by 2me plus Z is divided by E is divided by mg. I have to rearrange this. This is the equation for phase space, equation for phase space of the bouncing ball. Now from this equation we have to calculate the turning points. How you have to calculate a turning points? Once you have to see how we have to calculate the turning points. First you have to see at pz is equal to 0. At pz is equal to 0 in this equation, 1 is equal to z by e is divided by mg. So therefore z is equal to e by mg we are getting. This is the, so z value we have to write. Now one more point you have to consider, turning point at z is equal to 0 you are taking. So which one we have to get? Pz square is equal to 2me. So therefore pz is equal to plus or minus square root of, which one we have to get? Square root of 2me we are getting, plus or minus square root of 2me. Now we have to construct the phase space trajectory. We have to construct. How we have to construct the phase space trajectory? Once you have to see the equation for a phase space trajectory is, so what is the equation for a phase space trajectory? Equation for a phase space trajectory. What is the equations of the phase space trajectory? Once you have to see, 1 is equal to pz square is divided by, so 2me plus z is divided by e by mg. What are the turning points? So those are turning points. Z is equal to e by mg and pz is equal to, these are the turning points, plus or minus square root of 2me. Based on these turning points, you have to fix it in a force portrait for phase space of which plane it is, z and pz plane. This is the pz and z plane. First you have to put the point, pz points you have to put when z is equal to 0. That point is, so which one you have to consider? This one, plus square root of 2me. So now you have to take this point, minus square root of 2me you have to take. So when pz is equal to 0, you have to consider as a z point. So what is the z? Z is equal to e by mg. Is there any minus term? There is no minus term. So that's why now you have to coincide all the points and you draw the extrapolate lines you have to draw. For a single particle, that graph it will come. You have to take a multi-particle, your phase portrait, it will come like this. So this is your phase space trajectory of a bouncing ball. Phase space, which one it is? Phase space trajectory. Phase space trajectory of bouncing ball. Bouncing ball, very very important. So many times your competitive people are asked this question in many times. Now you have to see the answer. So what is your answer? Once you have to take your answer, answer 1 is correct, answer 1 is correct. This is the z and pz plane. Your graph will come like this, your graph will come. So this one is the correct one. Now it is not ellipse, is not in this direction, is not in this direction. So the option 1 is correct. So how simple it is. If you know how to solve the problem, so then it is easy to identify the answer also, right? Once you have to able to know the bouncing problem, one immediately you have to keep, you will get the trajectory or phase portrait like this. Clear? Once you like my teaching, daily I'm informing you, we started the CSIR and GATE physics course. In this course, mathematical methods of physics already finished. This recorded one is available now. Individual course also. Now we are started the classical mechanics. This live class and recorded classes is going on in these days. So if you really interested to join in this course, go to the Play Store and place the Quantum Online Academy app. From that app, you download it and you have to enter it. And after entering, you go to the courses. Our courses will appear in our app like this: CSR and GATE Physics, JL Physics, DL Physics, like this will happen. Whichever you want, you have to take. Otherwise, if you want to take only for mathematical methods of physics, this is also completed now. Complete portion of CSIR completed. If you want to take this course, so JL for DL, any course you have to prepare for this. Now this course is going to running live plus recorded course, live plus recorded one. This is live plus recorded one. That is the classical mechanics. Clear? Now this course is running now. Please choose these courses and inform to your friends also. You get the success in your competitive examination. Thank you so much. So please keep on listening our videos and share our videos and subscribe our channel and like our channel. Thank you so much.